Okay, hey everybody. I hope we're all having a great day. Hope we're all smiling pretty for picture day. I just want to, give you a video, screencast a video over section 1.3. We're going to take section 1.3 in 2 days. You'll actually find some of the easier stuff is in this set of notes. Tomorrow's lesson will be a little bit more difficult, not too bad. Still should be a review over Algebra 1, but it's a little bit more difficult than what we'll do today. So just as a reminder, whenever I give notes like this, it's really important that you write down all examples, write down all, practice problems that we do, any definitions or theorems that we do. Make sure that you write down everything that you need to know, because it's extremely important that we have the base knowledge, so that when I do get back and I can answer questions, that we have some depth that we can talk about. All right. Yep. Don't make fun of me. This is what I do at 10 o'clock on a Friday night. I know you guys are all probably at the football game, or well, it's probably over by now, but this is my life. This is what I like to do for fun. So don't make fun. All right. First things first here. That was the old key. I want to give you the opportunity to check some answers here. So let me just show the key here from the homework. Pause where you need to. Okay, I'm just going to scroll through, so pause where you need to. Here's the actual, yeah, I think that's everything there. Okay. Keep your questions for tomorrow. I'll hopefully have extra time to go over any questions that you have on this too, so should be all right. I know some of that set builder notation was kind of weird, but we'll just bear with me. Okay. So here are the notes for section 1.3, first day 1, square roots. Look, square roots. I'm so funny. All right, sorry about that. That took a while to progress. I gotta admit, that was not my best. That's not my best drawing of a tree with square roots. Oh gosh. All right. Now we've done something a little bit like this. We did something a little bit like it when we were thinking about the putting numbers in order from least to greatest. That whole thing. When I want to estimate a square root. I went through it just very quickly, but I want to re-explain what I did there and talk about it, because we know that square roots are irrational numbers, right? We know that square roots of non-perfect squares are irrational numbers. Perfect squares are 4, 9, 16, 25, 36, and so on, right? We know that the non-perfect square roots are irrational numbers. So how do we really estimate that? What if we didn't have a calculator? Well, we could think about where it falls on a number line, meaning, think about 55. What are the two perfect squares that are directly below and directly above 55? Well, think about, 6 squared would be 36, 7 squared would be 49. That's pretty close. 8 squared would be 64. So 7 and 8. So I've got the square root of 49 and the square root of 64. The square root of 55 falls right in between there, right? It's somewhere in the middle between there. Do we see how it's just a little bit closer? It's 6 units away from 49, while it's 9 units away from 64. Think about what that would mean in terms of the number. It's somewhere in between there, but it's a tad bit closer to the square root of 49 than it is the square root of 64. So I'm going to estimate, and again, keyword estimate, 7.4. Now I bet you can all check it in your calculators there. I don't have a calculator with me right now, but you get the idea. But it's around 7.4, I bet, if I was a betting man. I am, but Okay, so that's really what we're looking at there. You think about the perfect square directly above, perfect square directly below, and you think about where it would fall. Now, am I ever going to test you on that? Maybe. I mean, I could give you a problem just like I did in that order from least to greatest, and force you into figuring out, would it be, if I put this on a number line, where would it actually fall? Would it be closer to one side or the other? And you'd have to kind of take your best estimate at that. All right, but let's get into a little bit more of the algebraic properties of square roots. This should be review from Algebra 1. Should be, I say, should be. We'll see if it is. Properties of square roots. The first property that we have is called the product property. It says that anytime that you have a product of two quantities inside a square root, you can break up that quantity, those two quantities, into A and B, and actually physically break up the square roots into two different parts. Here's what I mean. Here's how this helps us. Think about 12. Isn't 12 just 4 times 3? 12 is really just 4 times 3. Right? It's just 4 times 3. A is 4, B is 3. I can take square root of 4 times the square root of 3. What is the square root of 4? Well, it's 2 times the square root of 3. And we have reduced our radical. That's a 2 there. 2 radical 3. You may have seen before what's called the buddy system of reducing down these square roots. This is really using the product property to reduce down the square root. But another thing that you could look at is the buddy system. What I mean by that is you take a look at 12 and you break it down into its prime factorization. You do the factor tree, 2 times 6, 2 times 3, and there it is for its prime factorization, 2 times 2 times 3, and then you buddy up. Got a buddy of 2, so I like to think of it, if I'm explaining this, it's, think of the square root symbol as this is a house, and you only get to leave the house if you got a buddy, right? If you got a date, it's date night at the square root house. You only get to leave the house if you got a date, and you only date the same numbers, right? Whatever, I don't know. Go with me here. So look, I've got a buddy of 2s. The 2 gets to leave the house, but 3, he's a lonely little 3. He has to stay inside the house. He doesn't have a buddy to leave the house with. Yeah. 2 radical 3. Okay. So that's the buddy system. We have a product property. And we also have the quotient property. Okay. Product property is obviously for multiplication. The quotient property is division. And it says really the same thing. If I have 2 quantities that are being divided, I can break up those quantities into the 2 numerator and denominator. And it works both ways. It's kind of one of those biconditional statements that we have. It works both ways. It works forward and backward. So I can put this back together and do this if I needed to, if this would help me reduce it at all. And look at that, it does. Okay, 60 goes into 15 4 times, or 15 goes into 60 4 times. So this actually turns into the square root of 4, which is just 2, right? Now, think of these as things that you can just use, put in your mathematical tool belt to use, okay? This is not something that I'm just going to say, like, use the quotient property to reduce this. No, I'm not going to do that. That'd be too easy. I'm going to just give you certain expressions and make you simplify them using the properties that we know, using the quotient property, product property, and so on. All right. Now, when I say simplify, just to clarify some directions here, that just basically means no decimals. Like, you can't just punch in the square root of 32 in your calculator and say, yo, it's like 5 point something, Yeah, it is 5 point something, but when I say simplify, that doesn't mean to estimate the decimal. That means to actually reduce it down. So let's reduce it down. Now, I don't care how you do it. You guys will probably use the buddy system. That's okay. So square root of 32 is 2 and 16, 2 and 8, 2 and 4, 2 and 2. A lot of 2's going on here. Buddy up. 2 sets of 2's coming out. 1 staying in. 2 times 2 is 4. Buddy on the end. No buddy on the inside. Sorry, dude. Okay, so it's 4 radical 2, or 4 square root of 2. We say it like that. Now, the product property would say to do it like this. Okay, the square root of 32 is really just, and take the biggest possible square, perfect square that's within 32. That's a, that would divide 32 evenly, like 16. Wouldn't this be that case? Isn't 16 times 2 36? Or sorry, 32. So that means it's a 4, because the square root of 16 is 4, and then the square root of 2. Get the same thing there. I think this is just more of an eloquent way to put it, a more sophisticated way to put it. This whole buddy system thing will work. It will work. It does work. And the reason why it works is because of the whole product property. Try the square root of 48. Why don't you pause the video, try square root of 48, and then play. Okay, so I'll do both things again. I'll do buddy system and I'll do regular. Not regular, but the product property. Whatever. 2 times 24, 2 times 12, 2 times 6, 2 times 3. Buddies, 2 times 2, and then a 3 on the inside. So it's a 4 radical 3 again. And that's multiplying on the outside. Yes, that is multiplying. Okay. This is where my analogy gets a little dicey. Because it's date night at the square root house, where you only get a buddy, you leave the house, and then what do the buddies do? They leave the house and multiply. Whoa, that's getting a little racy here for Algebra 2 class here today. Okay, but okay, I'm done with that. I'm not going to touch that again. Square root of 48 would also be considered 16 times 3, the square root of 16 times 3, right? Which would just be the square root of 16 and the square root of 3, which is 4 radical 3. That's another way to put it. Okay. So here's a quotient property one. Now, in this case, I'm kind of working backward, working the back side of that whole biconditional statement, where I can say, yeah, this is the square root of 25 over 36. I can say that this is the square root of 25 divided by the square root of 36. If it helps me, I could take that square root and divide it up in between the two parts of the fraction. And it helps me here, because it just turns into 5/6. Okay. This, obviously, square root of 49 over the square root of 16, 7/4. Okay. All right. And again, the product property is also biconditional, also work backward as well, work forward and backward. So like this is just the square root of 3 times 12. Now, fancy, that's nice. 3 times 12 is 36. Square root of 36 is 6. By the way, you really should have the first 20 square roots memorized. Okay, you really should. This is a little side note here, a little sidebar. You probably have 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100, right? Because that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You probably have the first perfect 10 squares, perfect squares memorized. You should start memorizing the first 20. My Algebra 2 teacher actually quizzed us on it. He gave us 1 minute to write 20 perfect squares. So basically, we had to memorize it. That was it. Let's see how much I remember. I have to do this from year to year. So this is the first time thinking about it in a very long time. 121, that's 11. 12 is 144. 13 is 169. 14 is 196. 15 is 225. This is where it starts to get weird. I know 20 is 400. And, gosh darn it. 16, 17, 18, 19. Man, I forget these. 16 is 2. I know it ends in a 6. It's probably 256. I'll check these in a second. 17 is 289, I think. 18 is, oh yeah, because 18 is 64. It ends in a 4. 8 times 8 is 64. It ends in a 4. So I know 18 times 18 will also end in a 4. So I think it's 324. And then 19 times 19, 9 times 9 is 81. So it has to end in a 1. So I'm going to say 3. Oh, man. Is it 51 or 61? I'm going to go 61. Let's see. Okay, I'm pulling out a calculator. Hold, please. Okay. Oh, I guess I can do it on this here, can't I? Okay, let's look here. Let's see how good I did. 16 times 16, 256. Boop, boop. Got that one right. Okay, 17 times 17. I'm pretty confident about that one. 289, yeah. 18 times 18, 18 times 18. Yeah. 19 times 19. Whoa, what in the world? What in the world? 19 times 19. Yes, I was right with the 6. Okay, so, wow, after all this time, I can still do that. I guess I'm a math teacher, so I should be able to. But you should really start to memorize the first 20 perfect squares. These numbers are really important. You should really start to memorize those. But, okay, off my soapbox. Let's try that one. Go ahead and try this one on your own. This one should be pretty simple, though. 20 times 5 is 100, so 10. Go ahead and try this one on your own. 500 divided by 5 is 100, so 10. Again, pause where you need to. Ooh, 147 over 3. I'm guessing that's 49. Yeah. It's got to be some sort of perfect square. 7. Okay. So all of these properties should have been review for you guys. Should have been review. Again, we'll work on some more difficult stuff tomorrow, but hope you all have a great day today. Smiling pretty.